Now we want to talk about how does the atmosphere actually produce the weather which is going to cause geomorphism, the carving up of the surface of the earth. So first thing we need to understand is the greenhouse effect. And so there are certain gases such as water and carbon dioxide, and then there are other ones such as methane, for example. So CH4, so that's methane. So those are three greenhouse gases. They act like a blanket, so that here's the earth, and then up in the troposphere you're going to have these greenhouse gases are up there, so that incoming solar radiation, mostly ultraviolet, can penetrate. Now, I just got through saying that most of the ultraviolet is going to be taken care of by the ozone layer. Well, some of the ultraviolet still manages to make it to the ground. And when it reaches the surface of the earth, it's going to heat it up, and then the radiation is going to go back into the sky, but this time it's going to be infrared heat radiation. And these greenhouse gases here are going to act like a blanket, and it's going to keep this heat from escaping into outer space, so that the surface of the earth is going to be warmer than it would be if there were no greenhouse gases. So in one respect, greenhouse gases are a good thing because it helps to keep the planet warm, but the more greenhouse gases you have, the hotter the climate of the planet is going to be. Okay, you need to know how a cloud forms. So a cloud begins as warm, moist air. So it needs to have water in it, and it's going to be in the form of a gas. But it's going to be a warm gas because warm things go up in the troposphere. So this warm air is going to start to rise in the troposphere. The higher up it gets, the colder it gets. Eventually it's going to reach a temperature at which the gas water is going to change to liquid water. Then you got your cloud, and then that water can rain back down onto the surface of the earth. Need to know what pressure is. So pressure, P, is equal to force divided by area. So if you take the force or the weight of all the air that's on top of us, pushing down on the area of the surface of the earth, that's the pressure at the surface of the earth. And we say that we're under 1 atmosphere of pressure here on the surface of the earth. Now, why is this important? Is because in order to make a cloud, air needs to rise. So that means that the pressure needs to be low. So under low air pressure, air can rise, and then when it rises, it can make a cloud. Okay, under high pressure, pressure is high, it's pushing down, it doesn't allow clouds to form. So that under low pressure systems, it tends to rain, and under high pressure systems, it does not tend to rain. Okay, you need to understand the Coriolis effect. Now, you don't need to know the formula for the exam, but you need to know that winds, as a wind system tends to be pulled to the right in the northern hemisphere by the Coriolis effect. So that if a wind is trying to blow from south to north, it's going to be pulled off course like this. It's going to be bent to the right because of this Coriolis effect. And the Coriolis effect is because the earth is spinning. So because the earth is spinning, it makes wind systems veer to the right in the northern hemisphere. So if a wind was trying to go in this direction, it would again be blown off course, and it would be bent to the right like that. So all wind systems are going to be bent like this because of the Coriolis effect. So why is that important? Okay, so what this does is it causes global wind systems on the surface of the Earth. So that if the Earth was not spinning, then the winds, the surface winds, would always blow in the northern hemisphere from north to south, always. But because the Earth is spinning, it breaks the convection cell, one convection cell in the north and one convection cell in the south, into 3 in the north and 3 in the south. Now this is important because at 30 degrees, so at 30 degrees latitude, it just so happens that, let's draw a picture. So here's a quarter of the Earth. The air is going up at the equator because it's very hot. It gets to the stratosphere, and then it starts to go north towards the North Pole, but because of the Coriolis effect, it gets blown off course, and eventually it starts coming back down at 30 degrees latitude. And what did we say? If air is coming down, it doesn't allow clouds to form. So at 30 degrees latitude, anywhere on the Earth's surface, it's going to be deserts. No cloud formation. Okay, but then if you go up to here at around 60 degrees latitude, then what's happening is air is rising there. And so you have lots of rain that is going to occur at 30 or at 60 degrees latitude. That corresponds to the United States-Canadian border. And then finally you have one more that goes up here to the top, and then it comes back down at the North Pole. And so technically the North Pole is a desert. It doesn't snow very much at the North Pole because it's a high pressure system. So the point is that this dictates where it rains and where it doesn't rain on the surface of the Earth, is these convection cells. And then the global wind systems caused by these convection cells then blow across the surface of the ocean, and it causes ocean convection cells as well. In between the convection cells, so here's a convection cell, so this is convection cell 1, here's 2, and then here's 3. So right here is going to be a jet stream, and right here is going to be a jet stream. And so jet streams are places where the wind is blowing very, very fast. So between 129 to 225 kilometers per hour. Then we need to include the effects of temperature on weather, and also the effects of moisture. So in the northern hemisphere, up by the North Pole, it's cold. When you're at the equator, it's very hot. So you notice you got the blue stuff up north, so that's cold weather. You got the red stuff near the equator, that's the hot weather. But then you also have to include, is it occurring over the ocean? So that's going to be maritime. So you can have moist cold air, or you could have moist hot air if it's over an ocean. If it's over a continent, it would be dry. So you could have dry cold air, and you could have wet, dry, warm air as well. So you have all of these different kinds of air masses that could either be dry, or they could be wet, they could be hot, or they can be cold. And then when they collide, they can produce rain. So that's going to be a front when they collide. Okay, let's take a break, and when we come back, let's talk about where water comes from and where water goes.